So today we're going to be talking about the force of friction, and it has an equation of Ff equals to mu Fn. This mu is called the coefficient of friction. And the specific thing that you need to remember that is directly relating to the contacting surface. So say for example, between a car tires and ice versus if the car is on, say, normal level ground, you actually have changed the coefficient of friction and it's a constant between the specific materials. Okay, Fn, it's directly related to the y-axis. So that means in order for you to calculate for Fn, you actually need to analyze the net force along the y. That's indirectly helping you to find Fn. And then Ff, because we're always mostly talking about opposing to motion, the Ff mostly involve the analyze of net force along the x directions. And depends on what they give you, we sometimes would just refer straight to the equation, but sometimes we would need to analyze the x or the y directions in order for you to be able to solve the problem. So examples number 1. A 3 kilogram block of wood sits on a horizontal wooden surface. The largest horizontal force that can be applied to the block before it starts to move is 14.7. Once the block starts to move, it only takes 8.8 newtons to keep it moving at a constant velocity. First one, calculate the coefficient of static frictions. Okay, things to note. When they're referring to the coefficient of static friction, that is talking about before it starts to move. Okay, like because after it's moving, we're now referring to the kinetic friction, right? So the static friction is before it starts to move, so we're going to be using the value of 14.7. And there's one extra catch that they didn't really tell you, is that when it's just started to move, you actually have an assumption that the acceleration is equals to 0. Okay, so part A, we know that we need to solve for the coefficient of friction. Hopefully you remember the symbol. The symbol for coefficient of static friction is mu. It's mu with an S, but I'm just going to say mu. So I have Ff equals to mu Fn. Okay, I am looking for mu. I don't really have anything else. That means I need to actually use the free body diagram and actually solve for it. So analyzing the free body diagram, there is going to be an applied force that's moving with it, and the applied force is 14.7 Newton. There is a frictional force, there is an Fg, and there is an Fn. We can calculate what Fg is by using the equation m times g. As I said before, you're totally allowed to do it while we're in the equation. Okay, and I'm just going to work this out. So m is 3 times the 9.8, so that's going to be what Fg is. So 29.4. Okay, so remember just now we talked about it, right? So in order for you to probably find Fn, you're going to be focusing on the y-axis, and then in order for you to find anything for the F, you're going to be focusing on the x-axis. So let's see what we can get. So we're going to split this up like F net equals to MA, like all those tabs. So along x, my F net along x is going to be forward minus backward, so FA minus FF, and so it's 147, it's 14.7 minus FF, I don't know what it is, so that's my net force, but I know that it equals to MA, and in this question, before it will start to move, it's just starting to move, so we're assuming that this is 0, so if 14.7 minus f is equals to 0, we actually can rearrange the equation for ff, and it would work out that ff is 14.7. So the static friction is 14.7. Okay, so we just found this, the FF for the equation. Now let's look at the Y. F net Y is Fn minus Fg. Okay, I know Fg is 29.4. I don't know what Fn is. But I do know that the acceleration is, we don't put the A as 9.8. I don't know if you recall. The acceleration is, this thing is on a wooden floor. There is no acceleration along the Y as well. So this A is equals to 0, meaning Fn is going to have to equals to 29.4. So now that when I have the FFF, the Fn, I can now sub it back into the coefficient of equation, coefficient of friction equation. So this is 14.7 equals to mu times 29.4. And the answer worked out to be 0.5. Watch your sig digs. I have used 2. So 0.50, and double checking what's the unit for mu. It doesn't have a unit. Okay, part B, determine the force of friction acting on the block if a horizontal force of 6.8 Newton east is acting on the block. So part B, I have my applied force equals to 6.8 Newton to the east. And they're asking you what is the force of friction. So important thing to note is, what is this trying to tell you? I have my applied force that's 6.8, but we just now talked about it. We actually need a total force of 14.7 in order for you to actually just get it to start to move. Can you move it with only 6.8 newtons? You cannot move it. So, same implication. This will be a little bit hard on a test or a quiz because I won't be prompting you these kind of questions, but you actually need to figure out that, you know what, the object actually wouldn't start to move. So that means acceleration is equal to 0 again. So if I analyze the forces along X, I have my forward minus my backwards, but it is not going to move. So FA minus FF is your overall net force. My acceleration is 0. So if I have FA equals to 6.8 minus FF equals to 0, that means you have calculated that the force of friction, you're going to move the FF to the other side, is also equals to 6.8 Newton to the west. Okay, part C now. They're asking you calculate the maximum magnitude of the static frictions that is acting on the block if you put an extra 2.1 kilogram object on top of it. Your free body diagram actually stays the same. So I still have an applied force that's pushing on it. I have force of friction, force of gravity, and force of normal. So the total mass that is now acting on it is the original 3. Now you've added another 2.1 kilogram on it. So the total mass of the whole thing is 5.1. What has it changed? If I change the force, does it make the force of gravity, does it make sense that it is the y direction that is now changing? So I'm going to redo my y direction. I still have Fn minus Fg equals to ma. Net force equals to ma. My object is still not accelerating along y, so I'm going to cross off that 0. I know that Fn is equals to Fg. I'm just moving it to the other side. And Fg is equal to mass times gravity. Mass times acceleration due to gravity. But this time, my mass is 5.1 times 9.8. So in this case, it's 49.98 Newton. That is the force of normal. And indirectly, what would it change? I am looking for the maximum of the static friction. I would like to calculate FF equals to mu Fn. The mu that I'm going to be using is the static coefficient of static friction that we found just now in part A. We found that it is equals to 0.50. That was from part A. So plug it in. So we're now figuring out what is the static friction. So I'm going to use 0.5 because that's my static coefficient of static friction times the force, the new force of normal. And so the new static friction is going to be 0.5 times 49.98. So 24.99. So I got 2 sig digs, so I need to write 25 Newton to the west. So it's important to know which friction you're talking about, right? Is it static or kinetic? And then talking about that, because now the next question is asking you to determine now the coefficient of kinetic friction. And if that's the case, if it's talking about the kinetic friction, make sure that I'm referring to the force that when it's moving. Okay, so I'm now using the FA equals to 8.8. So in this case, draw my free body diagram again. I'm doing question D. I now have a force of applied that's going to the east direction and is equals to 8.8 because I'm dealing with the coefficient of kinetic friction when it's moving. I would have force of friction going to the west, force of gravity going downwards, and force of normal going upwards. Net force along X, net force along Y. The reason why I need to do that is ultimately I need to plug it into the F equals to mu Fn equation. The equation is exactly the same, but you need to be careful which friction goes with what forces. I'm dealing with kinetic friction, so I'm using the force when it's moving. F net equals to MA. F net is FA minus FF. The forward force minus the backward force is equals to MA. And going back to the constant velocity, yep, check it again. A is 0. So in this case, FA is going to have to equals to FF. And we already said that FA is 8.8. So I know that the force of friction is also have to be 8.8. Do the Y side. Up minus down. Net force. And we talked about it. Does it matter? Is it up minus down or down minus up? It doesn't if there is no acceleration. Okay, so if you want to write Fg minus Fn equals to 0, it doesn't matter because it will come out the same. So Fn is going to equals to your Fg. The question is not clear. Do I use 5.1 kilogram or 3 kilogram? Can we assume that the 2.1 kilogram block is not there? Okay, so I'm just going to use 3 for the mass. So work out what my Fn is. So 29.4 newtons again. So now I have my Fn, I have my Ff. I'm going to plug it into the equation for the force of friction. So I know that Ff is 8.8. I'm looking for my mu. And I know that my Fn is 29.4. So divide both sides by 29.4. So my answer is around 2.993, blah, 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 blah. And I want 2 sig digs, so I have to round it to 0.30, which is reasonable. Remember, your kinetic friction is always less than your static friction. It's always harder to get something to start moving, but when it's moving, it's easier to push it. Okay?